Hello everyone, welcome to PMAC1140. In this video, I'm going to introduce to you how to solve a polynomial inequality and rational inequality. So in previous section, we already talked about how to solve polynomial equation, and you already know what polynomial equation is. Polynomial equation is a non-linear equation, which is not linear. As long as the degree is greater than 1, we call that non-linear. And if we use the inequality sign instead of the equal sign, we have something called polynomial inequality. But the thing is, can we solve polynomial inequality in the same way as we solve polynomial equation or not? So in this video, I will show you how to solve a polynomial inequality and rational inequality. Okay, so let's get started. So I'm going to put over here polynomial and rational inequality. Okay. Alright. So on the first part, let's talk about the method of solving polynomial inequality. Okay. One of the example of polynomial is a second degree polynomial, which is the quadratic. We go ahead and use the inequality sign instead of the equal sign. Then we have something called polynomial inequality or quadratic inequality, right? And the method of solving polynomial inequality is that we must be able to factor them out. If we can factor them out, then we can solve it by put it on the number line, okay, and try to find the interval notation that satisfies the inequality sign. Okay, so what I mean is this. What I mean is that as long as you can factor them out, and so for the zero, because we already know what does it mean zero, right? So for the zero, which is the value, the intersection point between the graph and the x-axis, right? And we put it on a number line, okay, and we check if which interval in that number line satisfy the inequality, then we have the answer. We have the solution. So the solution now, polynomial inequality will be interval notation, because we are talking about inequality now. It's not just one solution or two solutions. Okay. So for example, I have something like this. I have x minus 1 times x plus 3, alright, and I put this is greater than 0. Okay, so this is a polynomial. This is actually when you distribute them, will give you the quadratic, right? Okay, so if I use the zero product property to solve for this, then we have two values, right? We have two values, 1 and minus 3. 1 and minus 3. Now I'm going to go ahead and put these two values. Okay, I put these two values on the number line. Okay, so I'm going to put over here is minus 3 here and 1 here, and you see that. So you see that the number line right now is divided into three interval part, right? 3 part. This, and this. Now we're gonna pick one of the number in each interval, in each part. Okay. Then you plug into the original inequality, plug it in here, and you see which one satisfy the greater than sign right here. So first of all, I'm pick 2 over here, right? I plug 2 over here to so give you positive. right? And you pick the value between -3 and 1. For example, you pick 0. Okay, you pick 0. Then 0, 0, you have negative, right? You have negative. And you pick the value less than -3, for example, -4. You plug over here, which is give you positive. So you have positive, negative, and positive, and the original inequality is greater than 0. So it means that we're gonna take the positive one. Okay, so we're gonna take the positive one. So this is the one we're gonna take because it satisfies this inequality sign here. So this is the one we're gonna take. Okay, so the final answer will be what? The final answer will be -infinity to -3 parentheses, because we don't want to take the -3. Okay, we don't want to take it. It open circle because there's no equal sign. Union with 1 to positive infinity. Okay, so that is how you solve polynomial inequality. In this case, actually, this is quadratic inequality. The answer is interval notation. Okay. Okay. Example number 2. What if I have something like this? 3x, x minus 1, greater than or equal to 0, 10 minus 2x. Okay. So I recognize that when I distribute them, which give me the quadratic. Okay, distribute. Alright, distributed. Subtract both sides by 10. Alright, so look at that. I have another quadratic, right? And when I have this quadratic, I can go ahead and factor them. Because if you cannot factor them, we cannot find the value you put on the number line. So we have to factor them, okay? So it could be 2 here, 3 plus 5. Plus 5 here and minus 2 over here. Okay, right? Yeah. So now we factor them, and now we're gonna go ahead and show for the value we're gonna put on the number line, which is x equal to -5/3. We're gonna put on the number line with x equal to 2. We're gonna put on the number line. All right, now go ahead and put on the number line. So I have a number line like this. Okay. Oh, this is negative, and this is positive infinity. So I have -5/3 on this side, and 2 must be on this side. And you see that it's divide the number line into 3 parts. We're gonna pick the one of the value here in each part to check. So I'm gonna pick 3. So you can pick any number as long as it's greater than 2. So pick 3 over here. You plug over here, positive. Pick 1, negative, and pick -2, positive. All right. So what we need greater than equal. It means we're gonna take the one with positive sign. So the answer will be this one, right? And this is included, okay, because it's equal. It's included because it's equal. And now we're gonna take this here. So the final answer will be what? With -infinity to -5/3 bracket union bracket 2 to positive. Okay, so that is how you solve polynomial. Actually, quadratic inequality. It must be in factoring form. Okay, if it is not in the factoring form, then you gotta do some way somehow so that it's in factoring form. Okay, you have to do some way somehow so that if you cannot factor them, then you cannot solve polynomial inequality. Okay, because polynomial, it has 2 forms, right? Factoring form and the standard form. If you keep it in standard form, you cannot do it. So you see that I got it. This is standard form. Now I'm gonna change this to factoring form. So you always have to do like that. Okay, always. Okay. Let's see what else. How about How about this one right here? This is very interesting problem right here. Oops. Example 3. I have a problem like this: x to the 4 minus 12x greater than or equal to ax squared minus x to the 3rd. Alright, so let's put everything to the left hand side. That's right. Here you go. So I have something like that. And you see that this is not in factoring form. This is in standard form, right? So we have to factor this. So I have something in common. Yeah, GCF. So x in common, x to the 3rd plus x squared minus ax minus 12. Alright. But this is still in standard form. So you have to factor this. You have to factor this. So how are we going to factor this? So in order to factor this, you have to guess. Okay, you have to guess one of the value, and we use synthetic division. I mean, synthetic division is the concept we already learned. Okay, but in order to do synthetic division, you need to know what value you divide it by, right? So you have to take a guess. Okay, you have to guess. So you can guess 1, 2, 3, -1, -2, -3. Okay, let's guess 1, you plug over here doesn't give you 0. How 2? How about 3? You 3 raised to the 3rd plus 3 squared minus 8 times 3 minus 12. So guess, okay? And you see that, look at that, they give you what? This is give you 0. You go ahead and calculate. This is turn out to be 0. So it means what? It means 3 is 0. 3 is a 0. So I'm gonna go do synthetic division because 3 is a 0. So I gotta do synthetic division. Alright. So you have 1 minus 8 minus 12. So go ahead and drop it down. 1, drop it here. 3, add them up. 12, 4, 12. Here you go. It turned out to be 0 as the remainder. So the quotient will be this. The quotient will be this. So I have 3 is 0. So it means I have x here. I write them down because 3 is 0. So x minus 3 is a factor. Okay. And I have this as the quotient. So it means x 3rd degree, so you divide it, so you have x squared minus 4x plus 4. Oh, plus 4x plus 4. So greater than or equal to 0. Alright, now I keep factoring. Okay, x minus 3. This one I factor out, give you x plus 2 squared greater than or equal to 0. Okay, so if they give you the standard form, you gotta factor. So 3 value I'm gonna put on the number line. The first value is x equals 0. Second value x equal 3, and the 3rd value is x plus 2 equal to 0, so x equal -2. So I'm going to put those 3 values on the number line. Okay, so go ahead on the number line, positive infinity here, negative infinity here. So I have -2, I have 0 and 3. Okay, let's use different color. Okay, so I'm going to use the dot because original question is equal. So let's pick a value. Okay, pick 4, plug it in. So it turned out to be positive. Okay, and this is, you pick 1, it turned out to be negative. And you pick -1, it turned out to be positive. And you pick -3, it turned out to be positive. Okay, just go ahead and plug them in. Okay, plug it in. Go ahead and plug it in and check. Plug 4 over here, plug 4, then let's see what is the value, what is the number. So you plug 4 over here, so 4 minus 1, 4 minus 3 is 1, 1 times 4 is 4, 4 plus 2 is 6, 6 squared is a positive, so positive times positive times positive give you positive. You see that? So you're going to do carefully, right? So we want what? We want greater than 0, so what it means that we're going to take all of this. We're going to take this. So the final answer will be what? Will be negative infinity to 0. Okay, union with 3 to positive infinity. There you go. So that will be your final answer. Okay. So remember that you have to factor everything out. Okay. Otherwise you cannot do a polynomial inequality. Example number 4. Let me see. I can pick up one of the problem in the textbook. Oh, how about this one? Okay, how about this one? Next, it's interesting right here. How about this? 5 minus x squared and x minus 13 over 2. 5 minus x squared and x minus 13 over 2, and we want is what? We want it less than 0. Alright, so okay, it is that's a good thing because it is in factoring form already, so you just go ahead and solve for the value. Okay, and you solve for the value here. As long as you solve for the value, you know the number you're gonna put on the number line. So you put 13, so 5 must be over here, and 13 over 2, which is 6.5, will be over here. And you see that I'm gonna have to use the open circle because there's no equal. Alright, so let's pick this one. I'm gonna pick 7. 7, so it should be positive here. Right, so it must be positive here. There will be negative. I'm gonna pick 6, will be negative. And I'm gonna pick 0, which is positive, right? 0 with negative. There you go. Okay. And what we want less than 0, right? So whatever over here we're gonna take as the final answer. Of course, we don't want to take the number 5 because it's open circle. So my final answer will be negative infinity to 5 union parenthesis 5 to 13 over 2 as the final answer. Okay. If it is in a factoring form, then believe me, it's so much better. But for example, like this, you see, it's so much better. You just need to put you solve for the value, okay? Then you put it on the number line. But if it is like this, then of course you gotta try to factor them out, okay? You have to, for example, like this: x to the third minus x squared plus 9x minus 9. Example 5. X to the third minus x squared plus 9x, right? Plus 9x. Did I get it wrong? Minus 9 greater than 0. Alright, so this is in standard form, so you have to factor them out. So let's factor by grouping. X minus 1 plus 9, x minus 1 greater than 0, and you see the x minus 1 in common, and x squared plus 9 greater than 0. Alright, so this is an interesting thing right here. We see that the x minus 1 over here, you can solve for the value so that you put on the number line. But x squared plus 9, when you solve for the value, it turned out to be negative and positive I something. Because think about it, when you solve for this, you have something like this, right? So you have x equal to plus minus 3i. But I is a complex number. You cannot put on the number line. The number line is just real number. So in this case, what you see, you cannot put this on the number line. You can only put this x equal 1. So what happened over here? X squared plus 9. Okay, you try to recognize. Okay, x squared plus 9. So I'm gonna put it in this different color. I recognize that x squared plus 9 is always 0. It's fact, because it's always positive. This something squared is positive plus 9 is a positive number. It's always positive number. So you don't have to put on the number line. All you have to put on the number line is this one. Okay, negative infinity to positive infinity, and you put 1 on the number line. Okay, the open circle. All right. And this, I'm gonna pick 2 here, so the positive, and I pick 0 will be negative. Okay, and we're gonna take the greater than. That's it. So the final answer will be 1 to positive infinity. Okay, you don't have to consider this because this is a fact already. So you don't need this either. So the reason I wrote it down over here is just for you to see that we cannot put this on the number line. Okay, but on the real test, all you have to do is this. You can put this. You put x squared plus 9 greater than 0 as a fact. Then you don't have to put on the number line. Okay. All right. There's also another way to solve polynomial inequality. It is to use graphing calculator. If you have a TI-84, you can go ahead and put the function in polynomial function. Okay, and when you hit graph, and you're gonna find the intersection point between the graph and the x-axis, and you see that what part of the graph above the x-axis, okay, and what part of the graph below the x-axis. So depends on the inequality is greater than or less than. If it is greater than, you're gonna find an interval notation, okay, in which the graph is above the x-axis. And if it's less than, you're gonna find the interval notation for which the graph is below the x-axis. Okay, so I cannot show you how to use graphing calculator here, but if you have any question related to graphing calculator and how to solve polynomial inequality using graphing calculator, you can we can talk to, I can show you in class, face-to-face class. Okay. But for this video, you see that I don't have graphing calculator. Even I have it, I cannot put it over here on the screen. So please, if you have question regarding graphing calculator, let's do that in class. Okay. Now on the second part of this video, we'll be focusing on how to solve rational inequality. Rational inequality. Okay, so you guys already know how to solve rational equation, and you know what a rational expression is. A rational expression, it is the algebraic expression contain variable x in the denominator, right? So rational inequality, it is this rational expression that contain greater than, less than, excuse me, it contain inequality sign. So how are we going to solve it? So the method, the general method of solving a rational inequality is also to factor everything out. You're going to factor the numerator, you're going to factor the denominator, you solve for the value of x, and you put that value of x, okay, you put that value on the number line, and you're going to check the interval notation, okay, which one is positive, which one is negative. If it is positive, okay, if it is positive, you're gonna take the interval notation, okay, that give you positive sign, okay, all right. if the inequality, if original inequality is negative, we're gonna take the interval notation that is negative. It has a negative sign. Okay, so the general method is kind of the same as you show polynomial inequality. Okay, so I'm gonna put over here. Okay, I'm gonna put over here. The general method will be so I'm gonna put general approach. Okay, which is the first step is factor numerator and denominator, okay, as much as possible. Okay, then put the x value on number line. Okay, then the third step, again, check positive or negative interval notation. Right, positive or interval, check positive or negative interval notation. Okay, all right, so let's start with our first example. And I'm sorry guys, I have a bad allergy, so I have a problem like this. 4x minus 5 over x minus 2 less than or equal 3. Okay, this is a rational inequality, but you see the variable x in the denominator, but you see number 3 is still on the right hand side, so we need to move number 3 to the left. So on the right hand side is always 0. Okay, let's see. All right, then you're gonna do the same way as you solve rational equation. You're gonna find LCD. Okay, you're gonna find LCD. Alright, so I'm gonna go ahead and find LCD here. So LCD over here will be x minus 2. You multiply the top and the bottom by x minus 2. Okay, so it will be 4x minus 5 minus 3. You multiply the top and the bottom by x minus 2. So the bottom is still x minus 2. Okay, so if you guys couldn't recognize it, I'm gonna go ahead and put it over here so that you can see. So I'll multiply the top and the bottom by x minus 2. Okay, then I'm gonna have this. Okay, less than or equal 0. I mean, by the time we learn rational inequality, you guys are supposed to know how to solve rational equation. Or if you don't know how to solve rational equation by using LCD, combining letter, excuse me, then please go back to that concept. Okay, this is one of the first concept in college transfer. During the first week, the first month, okay, we already learned how to solve rational equation. Okay, finding LCD, you're supposed to know how to do that. Okay, then I go ahead and combine item. Okay, 4x minus 5, 6, 0. Give you x plus 1 over x minus 2. Alright, now let's check the numerator and denominator. You see that there's no way we can factor them. Okay, so look like the first step, we don't have to do anything. Now we're going to find a value so that we can put on the number line. So the value, okay, the value will be these two values. Go ahead and set it to 0, solve for that. Alright, and now we're going to put it on the number line. Alright, I'm going to put it on the number line. Okay, negative infinity, positive infinity. It's negative 1 here and 2 here, and we want to make a dot because it's equal. Alright, so we want to be included. Now you see that there's no 3 interval notation. Okay, so we gotta see which one we're gonna take. So I'm gonna plug our value 3 in here, positive. See that? Positive. Plug 0 here, negative. And plug the negative 2 here, positive. Alright, so what interval notation we're gonna take? We're gonna take the negative one because it's less than. Okay. Alright. But be careful right here. Be careful because you guys think that because it's equal sign we're gonna use the dot for both end, right? But the thing, because this is under the denominator, you cannot have 0 under the denominator. It means that right over here you cannot, oops, right over there you cannot, oh, sorry, right over here you cannot use open circle F2. You cannot use closed circle. Okay, you got to use open circle F2. Okay, because you cannot have 2 here. 2 minus 2 0 undefined. So you have to be careful. Okay, you have to be careful. It's not like polynomial inequality. You just need to look at the sign. You know which one is a dot, which one is a circle. But over here for rational inequality, you have to look at the denominator. The denominator never be a close. Okay, it's always an open circle. Okay, good. All right, so the final answer will be bracket -1 2 parentheses. All right, example 2. So the method is the same way as you solve rational equation, but now for this you gotta do more. You solve rational equation, then you gotta find the value you put on the number line. Alright, what if I have this? Okay. I think I'm gonna change this. -2 greater than 1 over x plus 3. Again, we're gonna move it to the left hand side. Okay, then we're gonna find LCD. So find LCD. So you multiply over here by x plus 3, and over here you multiply by x minus 2. Alright, then the denominator will be x plus 3, x minus 2, x plus 3 here, minus, distribute the minus in, plus 2. Okay, minus times minus become plus. And now we're going to combine that term. So you have 5 only, x plus 3, x minus 2. Alright, now we're going to find a value on the number line, and you see that everything has been factored already. So we'll have to find a value on the number line. Alright, so there's 2 values on the number line. And these 2 values is under denominators. No matter what, this is equal. We always use the open circle. Now we use the open circle for -3 and for 2. Okay. And now we're gonna check the interval notation. Positive. Pick the value here. 0, negative, -4, positive. Alright, we want a greater than, so we're gonna take this. We're gonna take this. Then the final answer will be -infinity to -3 parentheses. Even though it's equal, but must be parentheses here because it's under denominator. Okay, union 2 positive. Okay. There's some special case. So you don't have to factor, for example, like x squared plus 1. You know, it's positive already. You don't have to do that. Okay. Let's see. I can pick one of the problem in the textbook here. How about this one? Oh, that's kind of fun. It's got a great problem right here. X squared minus x minus 2 equals 3. X squared minus x minus 2 over what? X squared minus 4x plus 3. Okay, greater than 0. Let's change a little. Let's make it like less than 0. Less than equal. Alright, so this is not factor. Yeah. It's not factor yet, so we go ahead and factor them out. So we have x minus 2 plus 1. At the bottom here we have x, we have minus 3, minus 1. So we have a lot of value we put on the number line. We have x plus 1 equals 0, x minus 2 equals 0, x equals negative 1, x equals 2. We're going to put those on the number line. X equals 1, x equals 3. Alright. So we have 4 of them. We have 4 of them, put it on the number line. Okay. So let's do in order. Okay, so you gotta do negative 1 here. We have 1 here, 2 here, and 3 here. And at negative 1, we're gonna use a dot. At 2, we also use a dot. But at 1, we have to use the open circle because it's under denominator. This one also open circle. Okay. Alright, so how many intervals here? 1, 2, 3, 4, 5. So we're gonna check 5 intervals. Okay, pick a value. Pick 4, plug it in. Positive. Pick 2.5. Negative. Pick 1.5. Positive. Yeah. Pick negative 0.5. Negative 0.5. Negative. And pick negative 2. Look at it. Positive. Alright. So which one we're gonna take? We're gonna take less than equal. So we're gonna take this one. And we're gonna take this one. Alright. So the final answer will be what? Will be bracket negative 1, 2, 1 parenthesis union with bracket 2, 3 parenthesis. Okay. Okay. Alright, so I guess that's all. That's how we use the number line to solve rational and symbol and polynomial inequality. Let me give you the last one. This one is kind of very special case right here. So you have x squared over x squared plus 4 greater than 0. Alright. So you see that for this one you cannot factor, right? There's no way you can factor it. And if you look at carefully, x squared is a positive number. This is a positive number also. And you add it to the positive number. So the top is positive number. You divide by positive number. So it's always greater than 0. So this is, okay, this is a fact. This is true all the time. True always. And if it's true always, the answer will be negative infinity. Okay, because it's true all the time. Alright, so again, for solving polynomial inequality and rational inequality, the only option, okay, the unique option to solve it is to put it on a number line. We have to create the side table. You have to create the side table like this, okay? Side table, okay? If you use another method, we don't have it, okay? Which is will be wrong, okay? Will be wrong if you use another method because we don't have another method, okay? So you see that we have number line and the side table, the side table, the side table. Don't use any other method. We don't have it, okay? This is the only method to show polynomial inequality and rational inequality. Okay, so I'm gonna stop the lecture over here. If you have any question, please let me know and send me a message through Canva, and I'll be seeing you next time. Bye bye.